Generative AI has made outlining lesson plans almost instantaneous. But for educators, an outline is just a text file. The actual execution, building the quizzes, writing the rubrics, and formatting the worksheets, still requires hours of manual labor. This creates what we call the interface gap. It is the friction between receiving raw text from a large language model and actually having a deployable digital tool that students can interact with. An AI can draft a set of reading comprehension questions in seconds, but copying those questions into a form, assigning point values, cross-referencing common core standards, and building a matching answer key still falls entirely on the teacher. TeachSpark is an architecture engineered to bypass this bottleneck. It takes a raw pedagogical objective and handles the structural formatting automatically. By eliminating the interface gap, the platform shifts the educator's role. They are no longer manual data entry clerks formatting text. They are directors compiling automated instructional assets. TeachSpark operates as an educational asset compiler. The core operational mechanic relies on a central processing node. A teacher provides a single set of inputs, and the engine routes that data, instantly branching out into multiple distinct formats: a student-facing web app, a physical worksheet, and an answer key. The system executes this generation process autonomously. It requires zero coding, formatting, or design work from the instructor. To understand how this works in practice, we will examine the mechanical pipeline, how the platform ingests initial inputs, builds bespoke HTML, and automates the feedback loop between student and teacher. This architectural pipeline is how we successfully transition a raw pedagogical objective into a fully deployed, graded student environment. The compilation process begins at the input layer, where the platform ingests raw instructional parameters. This is the primary activity creation interface. A teacher can initiate a build by typing a lesson goal or describing an exercise directly into the text box. The input layer also handles dense, structured data. By dropping files into the upload zone, the system can ingest existing PDFs, legacy lesson plans, or even full semester syllabi to build out sequential curriculum units. The platform supports multimodal inputs, allowing educators to base entire interactive modules around specific YouTube videos. When pasting a video URL, providing the accompanying transcript is a critical step. This grounds the AI in the actual spoken content, preventing hallucinations and eliminating the need for a human to manually timestamp questions. Because of this highly flexible input layer, educators never have to start from a blank page. The engine adapts to whatever starting materials they possess. Once the parameters are set, the build phase begins. This compilation takes between 5 and 7 minutes to complete. That duration is a deliberate feature. While a standard AI chatbot might spit out generic text instantly, TeachSpark is programmatically assembling discrete, interactive HTML blocks, moving from direct instruction to practice to application and finally reflection. The system is not querying a database of pre-built templates. It is compiling unique HTML code and injecting exact standards alignment metadata from scratch, based entirely on the input variables. Because this is a live, dynamic build process, the generation will occasionally experience a timeout or fail to finish compiling.
When a timeout occurs, the architectural fix is simply to trigger a regeneration. The end result remains a fully custom-built, standard-aligned application. The primary output of this engine is an interactive, student-facing web application. This screen shows a generated exit ticket, featuring clickable multiple-choice selections and an integrated short answer text box. TeachSpark treats this web app as a flexible data state, enabling a process called bidirectional generation. A newly generated interactive activity can be reverse-engineered to produce a formal administrative lesson plan for the teacher. Conversely, uploading a static, text-based lesson plan will prompt the system to generate a brand-new interactive student activity. That exact same source data can compile offline deployment assets. This control menu allows the instructor to instantly generate print materials. These offline assets include perfectly formatted printable worksheets and comprehensive answer keys, complete with detailed scoring rubrics. TeachSpark operates on the principle that educational materials are fluid, interchangeable data states rather than fixed, static documents. Distributing these assets to the classroom is designed to be frictionless. Activities can be shared via a direct URL,
a scannable QR code, or seamless integration directly into Google Classroom. Once deployed, the student experience is governed by an asymmetric AI architecture. A solid firewall separates the active AI processing node on the teacher side from the student's interface. This imposes strict negative constraints on the student side. There are no required logins and absolutely no chatbot interfaces. The student interacts solely with a static, deterministic HTML web page. They never have access to generative AI. By removing the requirement for student logins and isolating the generative engine from the student link, this architecture prevents AI hallucinations from reaching the classroom environment. The final stage of the pipeline handles data retrieval, routing information from the student's device back to the teacher's dashboard. As students submit their work, their multiple choice selections and short answer responses are transmitted to the instructor in real time. To process this data, the system utilizes an AI review feature, which provisionally scores the short answer responses against the rubrics it auto-generated earlier. Human oversight is a critical component of this loop. The instructor always retains the ability to override any AI-generated score. While the AI accelerates the mechanical evaluation of the data, the final grading authority always remains firmly with the human instructor. The finalized student data is fully portable, ensuring it integrates with a school's existing technical infrastructure. Instructors can export these results as standard CSV files for seamless upload into any standard learning management system. Alternatively, the platform offers a dedicated Bluekit export format, which instantly translates the data into gamified classroom review sets. The overarching value of the TeachSpark pipeline lies in its ability to automate both the initial interface generation and the subsequent evaluation mechanics simultaneously. By automating the mechanics of digital formatting, the platform allows educators to return their focus toward instructional strategy.